Hey, in this session of the lab, this is Module E, Week 3, we're going to be pressure testing bottles. Now we're going to use water to pressure test with. Why we don't use air to do pressure testing is that stores energy, and during the release it's going to be very violent. So normally we want to do hydrostatic testing, and that means filling the vessel completely with water and removing all air. Now you're going to do this testing down in the test arena. I'm going to do it at the sink just for convenience of recording. Now when we do this, we need to pay attention to safety. The pump is going to be behind a safety curtain. The person pumping needs to stand behind the safety curtain. You're going to hook up all your connections. People are going to evacuate the area, get outside of the barriers, and then do your pressure testing. You're going to be able to see the results of the pressure testing on the gauge right here on this unit. Now let's talk about our connections here that we have. In the past, we've used some nice red connections right here. The problem is they didn't seal up with the bottle very good. We had to do a lot of Teflon and had a lot of issues. This semester, what we've got for you is a new connector that is going to come on and off of this air chuck connect. So to connect this, you're going to pull down this outer ring and you're going to stab that on there. That's how we're going to make our connection when we're ready to pressure up. Now what we're going to have to do is we're going to have to come in here and we're going to have to put this on our bottle. And what's nice about this connector is it has a gasket in there. So this is going to let us fill up our bottle and seat onto the bottle and tighten up on there. You're going to have buckets down there. It's probably just submerge your bottle and get it completely full of water. So my bottle is completely full of water at this time. What I'm going to do is this adapter right here has a quick release on here and a valve. What I like to do is when I'm tightening this up is pull this apart because the valve will seal off and I won't eject the water, introducing air back into my bottle. So I'm going to come back in here, tighten this up. I'm going to put my wrench onto the flats, make sure you get a good seating, and I'm going to come in here and tighten that up on my bottle. Now then, my bottle is fully filled with water and it's ready to be tested. Now to do that, we're going to come in here and we're going to put this fitting on to the unit, and then we're going to attach our hose to it. And again, you pull this back and push on. And so that's all ready to test. So let's talk about this pump system here. I've got the bottle removed temporarily so I can show you the flow of water here. We have a pressure gauge over here and we have valve 2. We don't need to be turning valve 1. What valve 2 does is, well, if we turn it clockwise and close it, it will let this pressure build up in the bottle. Now every time I pump this, it's pumping water out into the bottle and it's not going to let it backflow out. So if I put my finger over this real quick, it's building up pressure. If I relieve valve 2, it'll relieve that pressure. So for test, we're going to have valve 2 closed. To relieve pressure for any reason, we're going to open valve 2. Now the pressure reading is going to be caught on this gauge over here, and we're going to be able to turn that dial counterclockwise and zero it out. So again, you're going to go full 4 pumps. That means 1 pump, 2 pump, and you can probably go a little bit slower than that because that bottle is going to have to kind of stretch and it's going to adjust for those 4 pumps. We're going to let it sit for about 15 seconds and then we're going to come in here and read our pressure off of the gauge there. That's going to be our max holding pressure. Now then, let's go pressure this bottle up. We just learned how to use the pump system, and I'm going to go ahead and hook up my bottle because again, we have it completely filled and no air in there. So double check that. I'm going to come in here and clip this on. I now have my connections made, and you're going to be doing this in the test arena where you can pressure it up. I have my valve closed, and what I'm going to do is come in here and go 1, 2, 3, and 4. I'm going to let that hold pressure there, take my reading off here as it sits, and I'm going to take the reading off of the black dial because it stretched out and relieved pressure a little bit. So I'm going to be able to see that my bottle is very, very hard and very tight at this point. That's going to be our max holding pressure because we're actually stretching that bottle out. We want to capture that pressure. Now, what are we going to take this to? You guys are going to go to failure next. So again, we want to be safe. The person pumping behind the curtain, everybody out of the test area, and you're going to go till it bursts. Now, if you want to take your camera out and record it in slow motion, that's great. We'll try having a stand down there that you can put your camera in and record that so it doesn't move as much. What you're going to want to look at is the failure and document how this thing ruptured and where it started to rupture. Think about the things we talked about in lab in terms of hoop, lateral, axial strains, all that fun stuff, and think about why would that bottle burst and how would it burst. So after we've burst this bottle, what we're going to do is reinforce this bottle. And you're going to be issued 6 feet of this packaging tape, which has fibers in it, so it's going to be strong in this direction, but it's going to be weak in this direction because you're just dealing with the plastic tape that's holding that together. So you're going to have to come in there and reinforce your bottle and make it stronger and apply that tape as reinforcement. You're going to repressure a new bottle that you reinforced, and we're going to see if we get any differences in that. Now, if for any reason we get in a test and I have this thing pressured up and I need to relieve the pressure, that is valve 2, and I can hear it letting off all the pressure inside the bottle. Okay, now my bottle is becoming soft again. Okay, now I can disconnect things and take it apart if I needed to. So remember, we're doing hydrostatic testing on a burst test, and we're seeing how we can reinforce this bottle and make it improve. The next thing we're going to do is, once you guys get done, we're going to take you downstairs in room 140. We're going to have a machine that will actually do hydrostatic testing on true PVC. Let's talk a little bit about PVC here. This is a great deal. This is Schedule 40 2-inch PVC. It's rated to go to 280 psi at 73 degrees Fahrenheit. Meets these ASTM standards here. The deal is, we're going to take this pipe all the way to bursting pressure. We're going to establish that down on the bigger machine. We're going to be attaching it from end to end, and this is our coupon. There is a standard that governs tests like this. Again, we're going to remove all the air out of this so we don't have any stored air in there, and we'll be demoing that and letting you guys connect it up down there. The difference is, when we glue these ends on, it takes, if we look at the bottle, it says so many hours you can use this up to pressure, but the pressure that normally these things see is what? About 60 psi inside. They recommend staying under 280. We're going to exceed that 280. So when we glue these, we're going to put the ends on, and when we glue them, we're going to twist them a little bit. That's the proper way to glue PVC. That way we bond the weld, and it's not just going to come apart. We learned it takes about 48 hours before we can fully pressure these up to failure. So make your observations of how this pipe is going to break. Again, your hydrostatic testing, we're going to have different stresses in the hoop and in this direction. Which direction should it fail? Look at the failure point and see, and look at why you think it broke and where it broke. Put a little science into that, guys. Hope that helps out. We'll have fun.